about relationships, which is the next step in the systematic approach to facilities design. And relationships have to do with how close a particular department has to interact with another department within the facility. And a lot of those has to do with information flow or product flow or any kind of communication link that needs to happen. One of the main things is flow when you look at the actual factory itself. So we're going to look initially at a lot of the flow issues that happen within a facility. And it's actually one of the main aspects of facilities design when you're looking at any kind of efficient facilities, to really pay attention to the flow, which means how do things move through the facility. So first we're going to look at flow patterns, then the planning of flow, and then different ways of measuring flow. So flow patterns can be broken up into sort of three hierarchical levels. One is the flow within the workstation, how things move from place to place within the workstation, where the items come in, where they leave, where they're processed. And this a lot has to do with workstation design, maybe some of the things that you learned in IME 223. This is a little picture here of a workstation that some students in the facilities class designed for Prince Lionheart, which is a distributor of small parts for children. So this is just a design of the workstation. This is a miniature design, but looking at the flow within the workstation. And again, we're looking at methods within it, and ergonomic issues too fall under this category of flow within the workstation. Then we're also going to look at flow within the departments. So departments are areas that are made up of multiple workstations. So you can see here there's 2 workstations, and sometimes the flow goes in front of the 2 workstations from one workstation to the other. Sometimes they're back to back. Maybe the flow goes through and they have the same function, and they're pulling things off of maybe a conveyor belt that goes through. There can be an odd angle flow. This often happens not really as a design issue, but possibly to make sure that you're taking into account the shape of the facility. Maybe, for instance, there could be a column right here that they need to work around. Columns are actually something we need to talk about, because they are something that affects the flow in a facility. And if you don't initially plan for columns within a large facility, you really might find yourself in trouble later. In a big facility, usually columns are on a grid in the facility, and it's usually between 20 and 40 feet grid. So it could be a 30-foot grid or a 20-foot grid, but you need to know that, and you need to place that really initially in your product design. So if any of you are working in, well, you are working in big buildings, looking for where are those columns and where are those things that can't be moved. I think I talked to several groups about that already. And so this is another flow within department. This would be the cell manufacturing that we talked about last time. If this was a cell, you would look at how the products flow within that cell. The circular and front to front would be another one. You have to also consider where the aisles are when you're looking at how things flow within the department or between workstations. Then we move to sort of a more macro level, which is the flow between departments. This has to do with the facility and where things enter and leave the facility. It's often dictated by where the shipping and receiving is, and then the various ways that you want to manage the flow. It is best to have flow as straight as possible and as clear as possible. Sometimes you're not able to do that, but in this case you can see shipping and receiving are at the same place in the building, but as you moved this way down the building, you can tell where you are in the facility. So if a part is right here, you actually might be able to know how far along they are in completing that part, which is actually a good aspect of this kind of design. Another one is an S-flow. This is not quite as good, but it's better than having a mixed up flow. So in this case, I've overlaid the flow on top of a real facilities design, and you can see it sort of snakes through. Again, the shipping and receiving locations are at the same place. In this case, shipping and receiving are at the opposite end of the facility. Really, this is the most ideal. If you can design a building that has shipping at one end and receiving at the other end, it is the most ideal, because then you can have a straight through flow and things won't get as mixed up. Again, shipping and receiving this way, coming in one way and going out the other way. So thinking about flow in this hierarchical sense is something you want to do. So you look at effective flow is between departments, within departments, and then within workstations. So that's kind of how you first start with the workstation flow, and then you go to the department flow, and then you go to the facilities flow. This is an example. The picture on the side is an example of a company we did some work for called Say's Pure Gas. They're over by the airport, and they actually had this many buildings, and the flow was this crazy. And it happened because they started adding processes, and they didn't have room to add certain processes, so they put them in just wherever there was room. And this is really common. You'll see in companies that have grown over the years that you might have this kind of flow activity. One of the things you want to look for when you're doing flow analysis is you want uninterrupted path from origination to destination, which means you shouldn't have paths that cross each other, which is, you can tell that what's going to happen right here is there's a lot of congestion in this one area because there's a lot of crossing, or in this area too. And then also you want things to go straight through the facility. So this is the intersecting, and this is the straight through the facility. So when we look at a flow, we're sort of qualitatively understand the way the flow should work, but we also want to know how do we measure it. And there's quantitative methods and there's qualitative methods, and we're going to sort of combine both of those. The first one is a quantitative method. You can have a to-from chart where you actually look at the route sheet, and you can see when something is moving from one place in the factory to another, and you count that based on volume. Well, how many batches a day, how many units a day, and you put it on a to-from chart. So in this case, it would say that things go from quality control to the storage 12 times, and they go from inventory to quality control 2 times. Maybe this is times a day, pounds per week, whatever it is, but you quantitatively try to measure that from your volume charts. And then what you do is you collapse that down into what's called a to-from or a relationship chart. In this, collapse it down into a relationship chart. In this case, we say that things move from the store to quality control 19 times. Now, if you look at that, that is the sum of 12 and 7. So those together became this other chart, which is 19. And that's how we make this chart, and that's how you read this. So if you're going to go from quality control to inventory, it goes 2 times. That's how strong the relationship is. So this gives you a strength of relationship. Obviously, between shipping and receiving and manufacturing is the strongest relationship, and then the storage and quality control is another strong relation, and shipping and receiving and storage is another strong relationship. So you can really define the strength of the relationship by this relationship chart. Another thing you might want to do is look at this in a qualitative sense. So this is looking at the departments and not only using volume information about production, but also using other information about how important it is for people to talk to each other. You might want to look at interviews and surveys, organization charts, or observations. And what you do then is you use this AEIOU acronym and X to indicate what should be next to each other. So let's look at organizational relationships. So this is like span of control kinds of things, where we have the manager actually has to sit near Joe, Sue, and Jim, and that should be indicated then. That's a stronger relationship between those areas. Flow relationships, so looking at how things move from place to place. We talked about that, and there might not be something you can measure, but you will know that there's some sort of flow relationship. And then it can also maybe not be material, but people and information and money. And control relationships. So in this case, maybe material or inventory control needs to be in a central location so that everybody can access it. Maybe there's some automation or some control panels that need to be in a central location. So those kinds of things would be something you would also look at. Environmental relationships, there could be safety, temperature, noise, fumes, humidity, dust that you need to make sure that are either close to each other or far away from each other. Then dust and fumes would be something that you want to make sure that they're far away from people or at least isolated from them. Then there can be process relationships. So maybe things like water, if there's a water treatment, it actually needs to be near the wall, or chemical processing needs to be near that, or any kind of special services. So all of this happens, and you create this relationship chart. This is a scanned in picture from your book of the relationship chart. One of the things that's important in this is to notice that what you do is you list down all the departments, and you probably have already defined your departments before, so you use those same department definitions, and then you go through and you do a lot of thinking about why these things should be close together, and then you assign closeness. So like for instance on here we have an A here. The plant manager needs to be near the plant engineer. It's an A, an absolutely necessary operation, and the reason is because of 4, information flow is high. So we can look at something else like maybe I'm trying to find another higher relationship. Maybe this E relationship between purchasing department and the plant engineer. And the reason is, again, a flow information. So this is a real good key to see why things are